Welcome to IMTech. Welcome to the world of technology. It is impossible to imagine life today without technology. Technology provides solutions for the major issues we are facing today. Energy, the environment, water, mobility, communication, safety. Technology helps make operations faster, better, and cheaper. Thanks to technology, we can live the way we want to. We can travel, enjoy the leisure time activities, expand our horizons, and stay in touch with family and friends, no matter where they are. Technology is the tie that binds society. Electrical engineering, ICT, and mechanical engineering. Welcome to the fascinating world of technology. This is our world. Welcome to IMTech. Today's world is consuming more and more scarce raw materials to produce goods and energy. These raw materials are also turning up as a considerable proportion of our waste. The Kalundborg Waste Treatment Association, ZAC for short, has managed to use waste as a resource and to extract the maximum amount of energy potential and raw material from household waste. Through the use of the innovative maximum yield technology, the association's mechanical biological waste treatment facility works reliably and is self-sufficient in terms of energy use and has almost no emissions. The end result is that high-quality raw materials and energy sources are generated in the form of economically useful products from over 100,000 tons of waste each year, thereby making an important contribution to the conservation of resources and the prevention of climate change. MYT consists of 5 tried and tested, perfectly synchronized process steps. The first step is the intake of waste. The delivery hall. This is where the waste begins its journey through the MYT facility and also the last point at which it can be plainly seen. The digger loads 2 conveyor belts equally with the waste that has been delivered and sorts out large impurities and recyclable waste. The checked waste then proceeds in metered quantities to step 2, mechanical processing. Here, the waste is automatically separated according to material type and differences in size. The concepts and systems used are based on ZAC's many years of experience and guarantee safe operation and the systematic separation of fuels, minerals, metals, and the small amount of non-recyclable residual waste. The checked and processed waste then proceeds to the third step of the process, the biological stage. In the new and intensively tested defined aerobic mixing process, DAMP for short, the waste is selectively reduced in size and homogenized using a horizontal agitator. Processed water is added as part of a cycle, thus ensuring an appropriate, unchanging consistency. After being in the mixer for a short period of time, presses are used to separate water from solids. A portion of the microbially assimilable organic material is washed out with the resulting press water, then purified several times and used to generate energy. The water treatment. MYT incorporates a new practice-proven and mature water treatment. The processed water from the biological stage is mechanically and physically processed to separate coarse and fibrous materials. Microorganisms living in biogas fermenters create biogas from organic compounds. This biogas is then used in the nearby cogeneration unit to generate electricity and district heating. In the process, more electricity and heat is produced every year than the entire mechanical biological waste treatment facility itself needs. At the end of the water treatment process, purified water, water for agricultural irrigation purposes, or nutrient-rich liquid fertilizer are all available. Apart from water management, the ZAC is also setting new standards when it comes to exhaust air treatment. In order not to spoil the natural environment with exhaust air, which is usually quite pungent, a differentiated and innovative exhaust air treatment system is in operation. In the process steps, systems and conveying methods are enclosed, with the polluted air suctioned off on an ongoing basis and fed into the exhaust air treatment facility. Exhaust air, which is less polluted than from the halls, for instance, is purified in biofilters. Biofilters are containers filled with natural materials like bark mulch, in which microorganisms ensure that the odorous substances are mostly broken down into carbon dioxide and water vapor. Air washers and a regenerative thermal oxidation system take care of the purification of process air streams that are more heavily polluted. Step 4. Biological drying. After the separation of water from solids is completed, some microbially assimilable organic material remains in the solid material, thereby allowing a biological drying to take place that is both energy-saving and economical. In tightly sealed concrete tunnels, air passes steadily through the waste, providing the microorganisms with oxygen. These microorganisms feed on the material's organic components and produce heat energy for drying. After a brief treatment period, a homogeneous, dry, and fine solid material is available, which can subsequently be easily broken down into its constituent components. Step 5. Mechanical material separation. The mechanical material separation works completely automatically using a specially configured technology. Screening and sifting systems then break down the material from the biological drying process into different fractions. Energy-rich combustible materials as well as minerals are transported through special conveying systems to the loading stations and can be dispatched without requiring any further treatment. The goal has, at this step, been achieved: economically utilizable raw materials and high-quality energy sources that have been obtained from waste material. MYT refuse-derived fuels are available in various levels of quality with advantageous properties. The use of fuels containing biomass makes a positive contribution to climate protection. Fuels with a high plastics content are highly calorific and produce large amounts of energy. These MYT products replace, for example, fossil fuels such as coal and oil in industrial processes. This conserves resources and reduces carbon dioxide emissions, which is good for the environment. The products created by the MYT process illustrate clearly the great potential that exists to create energy and raw materials from household waste with minimum impact on the environment. This means that only small amounts of waste will have to be burned in incinerators. See for yourself by visiting the ZAC in Ringsheim. MYT can be seen up close by the public and is waiting to be explored and marveled at. The facility is situated amidst nature, where not only goats and donkeys can be found in the vivarium, but also where rare and endangered plant and animal species can be seen. Located among profitable vines in harmony with nature and accessible to the public, since 2006, something has been achieved here that lots of people would still consider to be a pipe dream: the generation of energy and raw material potential from household waste. What happens to the top quality energy sources created through maximum yield technology? Option 1, community energy generation. Option 2, standalone power supply of an industrial firm. Option 3, fuels and raw materials in the cement industry. Option 4, as a sixth stage direct from the power plant connected to the MYT facility. Closer inspection of Option 1, community energy generation. The high-energy refuse-derived fuels can subsequently be used in power plants to generate electric thermal and cooling energy. In the nearby thermal power station in Pforzheim, the co-incineration of refuse-derived fuels replaces up to 20,000 tons of coal, which represents some quarter of demand for coal. The RDF are stored in an accumulator silo and are injected into the pulverized fluidized bed combustion plant as required, are mixed with coal and agitated by air jets. The circulating fluidized bed combustion is extremely efficient in using the energetic potential of the refuse-derived fuels, and coal and particles of surrogate fuels burn out to the greatest possible extent. The whole process is encapsulated and functions as a safe, closed system. The recirculation and minimum combustion temperature of 850 degrees Celsius in the combustion plant ensures that harmful substances such as dioxins and furans are safely destroyed. At a temperature of 540 degrees Celsius and a pressure of 143 bars, up to 90 tons of steam per hour are fed into a turbine to generate electricity. A ratio of approximately 25% replacement of coal by refuse-derived fuels generates a corresponding supply of electricity of 5 megawatts. In addition, the residual heat is used as district and local heating, and likewise, with an output of up to 10 megawatts, provides a quarter of output by refuse-derived fuels. Since, because of their high proportion to biogenic carbon, the refuse-derived fuels are to the greatest possible extent CO2 neutral, a positive contribution is made to climate protection. Whereas natural gas must be imported from Russia, for example, or coal must be imported from Colombia or South Africa, refuse-derived fuels have one more thing clearly in their favor. The procurement channels for these energy sources are markedly shorter, for they are sourced from neighboring households. This means that refuse-derived fuels are more economical, can be produced all year round, and can be stored without problems. Option 2, standalone power supply of an industrial firm. Kurla Energie AG in Oberkies specifically generates for the standalone power supply of a paper factory the total energy requirements for the industrial site. In obedience to the well-known functional principle of the pulverized fluidized bed combustion plant, here also RDF replace finite resources such as coal and gas, and thus contribute a substantial portion of the company's positive economic and ecological balance sheet. The paper produced as consumer goods is given back in turn to the end consumer, and therefore to our households, and consequently some of it ends up again in domestic waste. The circle of retrieving refuse-derived fuels closes again. Option 3, fuels and raw materials in the cement industry. The world leader in building materials manufacture, Holcim in France, has been using RDF for many years now in the production of cement. The raw materials delivered from the quarries are combusted in a rotary kiln at temperatures of approximately 1,450 degrees Celsius to produce what is known as clinker, a component of cement as a finished product. The high energy requirement for this drying process is partially obtained from refuse-derived fuels. In addition, the ash resulting from the RDF is added and mixed in to form components of the cement. It thus does not have to be disposed of, but rather serves as an economic and ecological raw material. Option 4, as a sixth stage direct from the power plant connected to the MYT facility. In the recovery possibilities presented in options 1 through 3, the RDF were safely transported to the purchaser after the fifth stage of the MYT facility in walking floor trucks. If a power plant is directly connected, not only can the refuse-derived fuel be used with immediate benefit, but the energy recovery and the exhaust gas purification can be combined and optimized. At the Rostock RDF Thermal Power Station, The exhaust gas from the neighboring waste treatment plant is directly fed into the combustion process. 40,000 cubic meters per hour fed directly into the combustion plant. A closed circuit in the interests of the environment and efficiency. Generating the maximum raw materials and energy content from household waste, and the further use of refuse-derived fuels to generate electric power, thermal, and cooling energy in efficient combined heat and power. That is MTEC's world of the future. Further information can be found on the internet at www.myt-ringsheim.de and www.mtec.de.